So here we go. I'm offering the Spring Equinox Challenge to all the people that believe in the popular flat Earth that have the sun and moon doing circles over some sort of AE map. And what we're looking towards is March 20th. This is the Spring Equinox 2017. In the Northern Hemisphere will be at 5:28 a.m. All times are central. So check for your own location. But on the equinox, we are going to see a 90-degree east sunrise, 270-degree west sunset. And let's see what the problem with that is. So here's the problem. On the equinox, the sun rises 90 degrees east and sets 270 degrees west, not just at the equator, but everywhere on Earth. So here we are at suncalc.org. And I've got it set close to the equator here, and you can see that the path is coming up from the east. It's setting 270 degrees west. And the unique thing about the equator is that the sun's solar noon declination is 90 degrees overhead. So if you were to hang a plumb bob, the shadow would go neither north nor south of the plumb bob. The sun goes directly overhead, and that's true for all the places along the equator. But it rises 90 east, that's 270 west everywhere. So we'll just start moving this around, and you can see that here's the rise angle, here's the set angle. You see that the higher you go, they're creating this illusion that it's coming up a little bit higher north, south like this. But if you drag this slider and you come around here, you'll see that they have some sort of fake thing going on because they're not showing sunrise yet. Sunrise, if you look at the altitude right here, it's still below the horizon. Okay, they have some sort of like over the ball type calculation going on here. Once you get to there, it's at 0.17 degrees above the horizon, and look, it's coming up at 90 degrees. When you bring this all the way through here, you're going to have the exact same scenario where once your altitude goes to zero, watch what your heading is. Boom, 270. Okay, so that's way up north. Let's check it down south here. Same thing, it looks like the lines are curved down a little bit. They have this same little deception going on. Just watch the altitude when it gets to zero. Right there, 90 degrees. Came up 90 degrees there. And it's going to come around. And once your altitude gets to zero, boom, 270. Okay. So we're looking at the extreme north, we're looking at the extreme south. Every place on Earth, we can do it, whatever continent you want, just pick and choose. It's all 90 east, 270 west. We've got it down here in Africa. We've got it over here in Oceania. This is a new terminology to me. That was always Australia to me, not Oceania. All right, so what's the big deal with the sun rising 90 degrees east, setting 270 degrees west everywhere? Well, the big deal is we're not on a spinning ball, and the popular flat earth channels have been promoting the idea that we're on top of some sort of AE map with the sun and moon doing circles like this. All right, so this is the Gleasons, and they'll tell you, oh, we don't necessarily promote the Gleasons. I don't care what map it is. If it's circular in shape, laid out like this, as an AE map is, and they say that the sun and moon are doing circles over it, here is the problem. So on the equinox, we know that the sun is directly overhead of the equator. So here's Ecuador. And then Quito is close. We're just going to draw a line here from approximately where we think Quito is up to the North Pole. All right, so this would be due north, right? So now I'll grab the protractor here, set it down. Now we snap off of this line, and then I type 90 and hit enter, and that line right there is perpendicular to the one that we made up to the North Pole. So this right here, let me grab a cursor instead. This right here would be 90 degrees east and 270 degrees west. Okay, so if the sun is doing a circle around the equator right here, how would it be coming up 90 degrees east this direction and setting 270 degrees west this direction? Well, this is neat because right about here is Toronto, and Toronto is where my buddy Ronnie of Event Skeptic lives. So let's just set the protractor there, swing this around, hit 90 again. So Ronnie's up in Toronto, and what's he gonna see? He's gonna see the sun rise 90 degrees east, see it set 270 degrees west in Toronto. Okay. Now let's take a line from, this would be about Ushuaia, Argentina. This is one of our most southerly cities. So now we've got that line. We'll grab the protractor, snap it on the end there, snap off this, hit 90. And so people in Ushuaia, Argentina down here, they're going to see the sunrise 90 degrees east, set 270 degrees west out here. Do you see a problem? Supposedly the sun is doing a circle over the equator. Here's the equator. This is where it's not going to cast a shadow to the north or the south. We know that the sun's directly overhead of this position, and we have the sun rising 90 degrees east, setting 270 degrees west here. Well, let's continue to make this more and more absurd. Now I'll add Austin, Texas, and grab that protractor, come up here, snap around here, 90. So I see the sun rising from this direction and setting this direction. Now let's keep moving this around here. Let's do New Zealand. Alright, so we'll draw a line from New Zealand up to the North Pole. We'll grab the protractor. We'll snap off of this, come around here to 90. And they see the sun rising from this direction, 90 degrees east out here, setting 270 degrees west out here. Up here is the equator. Okay, the sun's supposed to be doing a circle on the equinox over the equator. Let's keep going here. We've got let's do something. I think Sydney, Australia is about here, and we'll grab that protractor, snap off of this 90 degrees. So they are seeing the sunrise over here, set over here. The sun's supposed to be doing a circle up here. Let's do Perth. So Perth, Australia, I believe it's right about here. Come up here. And the protractor, snap off this 90 degrees. They are seeing the sunrise here, set over here. And let's do one last one. South Africa. We'll do Cape Town. How does that sound? So we'll draw a line from Cape Town up to the North Pole. Grab the protractor. Snap off of this. So they see the sunrise over here and set over here. All right. So the equinox absolutely disproves the possibility that the sun and moon are doing circles over some sort of circular shaped AE map. All right, hopefully Hopefully I don't have to do any more locations. I mean, I could do anything, any point around this the so-called ice rim that doesn't exist. Okay, Antarctica is not an ice wall that goes around this. There is no dome. This is not an enclosed world. That's all propaganda. That's lies. That's deception. Any point around this ice rim right here on the equinox, you can look at the information on SunCalc. The sun is rising 90 degrees east, setting 270 degrees west. And that would be true of any point that you could pick around here on this non-existent ice wall. So you've seen 5 or 6 pictures of an ice wall, and you've been told that it's all the way around, and you believe it. And you're just doing it from 5 or 6 pictures. It's not true. This whole model right here with the sun and moon doing circles is not true. It doesn't work. So I'm going to make this challenge even more difficult because for this spring equinox, we're not going to just be looking at the sun's rise and set angles of 90 degrees east, 270 degrees west. We're going to bring the moon into the picture as well. Now I have a video part 6.4 bi-monthly moon equinox debunks the ball and popular flat earth model DPS's definitive proof series. And in this I covered the lunar standstill. There's an 18.6 year cycle between where the moon's meridian passing to the north and south. It varies in width. And at its narrowest, it's 18 point something, and it gets up to 28 point something, and I'm going to show you that chart now. So I'll leave links to this in the description, but this is the monthly lunar standstills 2001 to 2100. And in the introduction here it says the extremes of the moon's southern or negative declination ranges from about minus 18.2 degrees to minus 28.7 degrees. Similarly, the extremes of the moon's northern or positive declination ranges from 18.2 degrees to 28.7 degrees. So when you scroll down here, you get into these charts, and you'll see that it wasn't too long ago. Here we are in 2017, but back here in 2016, we've got in March 18.2. So this is when it was at its narrowest path as far as the latitudes that the moon was traveling between. 18.2 south and 18.2 north were the latitudes that you could see the moon's meridian passing between. So now we're in 2017 and we're going to be looking at the equinox. Here's March 21st. This is very close. So we're at 18.912. So if we look at the latitude of 18.912, now notice this is a minus. This is going to be a southerly latitude. This is where the moon is going to be directly overhead on the equinox. So here we are at mooncalc.org, and I've got it set up by Sydney here. We know that what we're looking for is the moon's meridian passing being 90 degrees directly overhead, and we know that it's in the south. We know that it's like 18.9 degrees. Sydney's farther south than that, and so here you can see that if I drag this slider, the moon is rising from an angle that is south of east, all right, down here. And then it's going to come up to a meridian passing of 74.86 degrees. So we need to start working our way up north here. Now, each time I click further and further up north, you'll see that this space between its origin point and the moon's meridian passing are going to get closer and closer to each other. So we're working our way up the coast, and we get up here near Townsville, and we see that now all of a sudden they're very, very close to each other. And if you look at this, so here's the angle that the moon is rising from. It's coming up from the south. This is coming up from south of east. And it's going to get up to its meridian passing. And here we got 89.69 degrees in Townsville. This is a very close hit to the moon being directly overhead. Now, Townsville comes in at 19.259 degrees. We've got a little bit of variance here as far as what that chart was showing. But this is where the moon's meridian passing is going to be directly overhead, and then you can see when it sets, boom, it's setting way south of west. So it's rising south of east, it's setting south of west, but it's coming directly overhead at this 19 degrees south. Now I'm doing the same thing in the Western Hemisphere. So this is 18 degrees, 53 minutes. This is a spot in Chile right here. If I drag the slider, you're going to see that it's rising from the south of east. It's meridian passing at this latitude, 18 degrees, 53 minutes. Its elevation angle is 89.75 degrees. This is directly overhead, and then it's going to come and set to the south of west again. Now I'm just going to back this up a little bit here and show you that the farther south you go, the more extreme the rise and set angles will be. You see how these angles have become steeper? So now the rise, I'd have to go to the day before, but you can see now when it's setting, it's at 239 degrees here. If we went to these islands, look at how steep the angles are getting now. So it's setting at 214 degrees, all right? So the farther you are away from the equator, the more steep these angles become. So as we work our way back up here, now we have these wider angles. They're all south of east, they're all south of west. And now the farther north we go, these angles have become more and more severe, steeper and steeper. Now we're up here in Alaska, and look at how tight these angles are again. Now we've got the rise coming up at 146.7 degrees. This is where it's rising from. And here's where it's going to set at 212 degrees. Everything is south of east. Everything is south of west. All right, so we're going to do this in SketchUp together. I'm going to grab the circle tool and pull a circle off of the North Pole down here to what would be about 19 degrees south latitude, which would be right about here. Let's make this visible again. Now that Townsville, Australia, would be right about in this area right here. So I'm going to draw a line back up to the North Pole right here. Now let's get the data that we need from timeanddate.com. Here's Townsville, Queensland, Australia. This is for March. Now you can see here at the 20th, it shows a moon meridian passing of 88.8 degrees. Then on the 21st, 89.6 degrees. So right here is when the moon's meridian passing is going to be directly overhead. And the angles that we're looking at are 110 degrees for a moon rise, 250 degrees for a moon set. So 110, 250. Let's go back here and plot those out. Grab the protractor. We will go 110 and 250. So what we're looking at here is a moonrise angle coming in from this direction right here, coming up to this point. The moon's meridian passing here 90 degrees overhead, or really close. We're just using Townsville because it's a city that's very, very close to this. You can fine tune it even more if you want it to just be Perfect. But this is just for reference. So it's rising south of east. It's coming in at 110 degrees. It's becoming visible. Circles around, and then it's setting at 250 south of west. Now, these angles, it is rising to the south, setting to the south, east and west, everywhere. Not just this place. Take any point along this 19-degree latitude. It's rising and setting south of east and west, but it's not just that. It's everywhere. Everywhere on the whole earth. It's rising south of east, setting south of west. So we're going to combine the equinox of what the sun is doing and what the moon is doing, and we're going to create a challenge for all you people that believe in the popular flat earth, all right? The popular flat earth AE challenge. Please explain to me how the sun can be rising 90 degrees east and setting 270 degrees west everywhere on Earth if the sun and moon are doing circles over an AE map. In addition, explain how the moon is rising south of east and setting south of west when we know that the moon's meridian passing is at about 19 degrees south latitude. The last part of this challenge is that you cannot use any of Dr. Zacks' apparent sun or atmos plane CGI disinformation. The reason why you cannot use any of Dr. Zacks' CGI apparent sun, atmos plane, refraction, CGI disinformation is covered in the March 1st episode of Beyond Flat Earth. This is very current at 28:55. I'll have this all linked up. I read a series of comments between me and a person whose user's name is FE Astronomy, who claims to be in day-to-day work with Steve Torrance, the originator, the creator of the CGI that Dr. Zack has been using. So I'm just going to point out a few things from this real quick. So here's some of that conversation I had with FE Astronomy. Now I'm just going to paraphrase some of it. I'm going to read others of it directly. But it's all right here, so you can actually stop it, pause it, read it yourself. But the important part is coming up in just a few seconds here. And then I'm going to start reading about now. Flat Earth Astronomy says, okay, let's try a different approach since I am seeing the links in the thread and you don't. Go to Steve Torrance channel on YouTube and find the Veracruz, Mexico model. Now we are well aware of the other astronomical errors in the AE projection. Bingo! The purpose of me giving this as an example is to show what happens to the star trails with a JPL star data mapped AE projection. As soon as you model an atmos plane, you see the southern sky also has a rotation point. In this example, it's below the horizon as it should be from that location. I say, do you know Steve at all? Can we reach out to him to model the same city in Mexico with the sun, moon, and stars for March 20th, 2017? I will try as well. He responds, yes, I speak to him on a daily basis for our research. Currently, we are preoccupied with trying to find a way to model magnetic flux fields or at least replicate the visual effect. To what purpose, may I ask, would you like this model to be made? I say, I am going to get real-world observations for these three things on March 20th, 2017. Let's see if they match. I will be making a video, that's what this is right here, about it regardless, but it would be nice to have your model to compare it to. Since you wanted me to address it, I am going to. I'll be putting out the video very soon. Any way you can bump it to the top of your priority list? He responds, the AE model is only accurate on the 90 degrees overhead positions. We use that projection since all star data is projected on the AE projection. It is not an accurate model. It is not an accurate model. so far we got rise and set times lined up over the year, but the rise and set azimuths are way off for obvious reasons. For obvious reasons. The rise and set azimuths are way off for obvious reasons. So then I respond, this seems like backpedaling. You asked me to look into this and I am. If you want 90-degree overhead, please do the simulation for Townsville, Australia. The moon will be 90 degrees overhead at its meridian passing on March 20th, 2017. If you want to put your CGI program to the test and see if it matches what we witness in reality, this should be really simple. If you are using the CGI program to create disinfo to support an impossible AE model, I'm going to expose it. Either way, I am making the video and bringing full attention to the real observations on March 20th. If you think your atmosphere can account for what we witness, let's see it. If you do not think it can account for what we witness, then it's time to scrap it and make a public apology for misleading people.
How many of you think that the flat Earth model doesn't make sense because the sun would never rise and set, but instead be visible 24 hours a day? Welcome to the Steve and Dr. Zacks show.
And 15 months ago, I started to work on this with Chandra Seke, aka The Man, and then we teamed up with Steve Torrance, and together we solved this puzzle. If our theory would work, and we had no idea how to test it. Steve already had the flat Earth model designed in his software, but there was something missing from it, and this something was the atmosphere. And we had no idea how to add this atmosphere to his model. And by coincidence, Steve found out that his program is capable to model the atmosphere exactly how it is. So he took the data from the internet and built all the layers of the atmosphere, and suddenly the magic happened and everything started to make perfect sense. And when I say everything, I mean everything. The sun started to rise and set, and it started to match reality more than the globe model does.
And all we did to make the flat Earth model work was add the atmosphere exactly how science represents it. We didn't make it up.
Now, solving this problem doesn't mean that we solved everything. We still have a problem with the elevation angles, because the sun that we see is not in its real position. What we see is just the apparent sun. So imagine the real sun is here and the fake sun is here. The shadow that you're going to get is going to follow the apparent sun and not the real sun. And this is not what we want. Okay? So the elevation angle that you're going to measure with the sextants or with any other tool is not the angle of the real position of the sun. It's just the angle of the apparent sun. And we're still working on how to locate the real sun that we never see. Once we locate it, we will be able to get the exact elevation angles of the real position of the sun. And by doing that, we can draw the flat Earth map from scratch.
So here is that Steve Torrance channel on YouTube. You can see that most of his videos are dedicated to CGI, some program that they admit does not match reality when it comes to the rise and set azimuths of the sun, the moon, the stars. That they do not match, they are not accurate. And this is what Dr. Zacks is using and promoting as being truth and being the answer, in that we have some sort of apparent sun or a fake sun, and that we can't use measuring instruments like sextants to see where and what angles the things are happening at. It's unbelievable, really. So to all the Dr. Zacks and the Steve Torrance and the flat earth astronomies out there, anybody else that believes that the sun and moon are doing circles over an AE map, the challenge is March 20th. Take a look at this Townsville, Australia, and explain how the moon is rising at 110 degrees, coming in from the southeast. setting at 250 degrees, setting south of west. And this has the moon's meridian passing directly overhead, right overhead. And this is south of the equator, where supposedly the sun is going to be doing circles around this point over an AE map and rising 90 degrees east and setting 270 degrees west everywhere on Earth. This is the challenge. Explain it and do it with some sort of non-CGI program that is admitted to not work. The reason why I've added the moon to the Equinox challenge is because of the deceivers out there that are going to say that the sun's an apparent sun and it's just a reflection and we don't see where the true sun is. Even though that this is what people have navigated by for centuries before things like GPS, the moon's a little different. The moon isn't too bright. You can film it with a P900 and you can see like right into the craters. And are you going to say that the moon's an apparent moon and that it's also a reflection? And once again, negate all the navigation that's been done by it. So the moon is rising south of east. It's coming up to its meridian passing at 19 degrees south latitude. It's setting to the south of west. Yeah, this is something that you gotta take into consideration in the Equinox challenge as well. So both the sun and moon. And explain it to me how this is happening without using the apparent sun CGI model. Thank you. So for all of you out there that are true seekers, please be prepared for March 20th. Have your compass ready. Go out and record the angle of the sunrise and sunset, the angle of the moonrise and moonset from your location. And if you're anywhere near 19 degrees south latitude, please shout it out. We all want this information. We all want to look at it. There is evidence in this information here, these angles, that prove that we're not on a spinning ball, that the popular flat earth model does not work, and that this is only really possible in a simulation. So please go, do, seek, share.